Okay, now a very simple model and just technical introduction to a model that is used to present evolution of interest rate. So we learn geometric Brownian motion, and we can use this model to simulate the behavior of logarithmic rate of returns, and then we can apply this rate to some prices of equity assets of some stocks. Now we have an introduction to behavior of interest rate and to modeling of interest rate. And to a certain degree, this is a very simple or a very similar logic to geometric Brownian motion when we think from this practical application point of view. But there is one key difference in mechanics. So Vasicek model is based on speed of reversion to some long-term data, some long-term mean. In case of geometric Brownian motion, we have assumptions about first and central moment. So we have this mean and we have this volatility or variance. In case of Vasicek, we have long-term mean or long-term expected value of interest rate. We have some volatility, but what is interesting here is that we will model evolution of interest rate changes. So we will model and show how we will revert to this expected value from our current level. In our exercise, we have long-term mean of 3.66%. It comes from some I don't even remember, from some interest rate that I modeled. We have some volatility, but an assumption is that we start with 2%, and we will revert to this long-term mean level with some given speed of reversion. In this technical introduction, all these assumptions are given. We will just use the formula that shows us what's the change in interest rate. So the change in interest rate is equal to, in brackets we have difference between long-term level and current level. So we have this difference, and we will decrease this difference with certain speed of reversion given. So our parameter A is speed of reversion, B is long-term level, R is our current level, and of course we will revert to a long-term level, but there would be some stochastic part around this evolution process. This evolution again, this stochastic part again is taken from Wiener process. So we again will use normal standard inverse distribution with random probabilities as an input, and this will show what's the volatility around our evolution, around our reversion. And again, this is change in interest rate level. So if we have this formula, we will be interested in calculating what's the speed of reversion times the difference. So the difference, if I have a long-term mean here and my current level is 2%, right? So this would be this constant part without, for now, this t index. This constant part, and of course to this constant part we need to add volatility around this evolution. So volatility is fixed. We'll multiply this by this Wiener process. Hence we will get back to this long-term mean level, but with a certain speed, and around this evolution there would be some volatility. So if my initial rate is equal to 2%, and if I have my change calculated here, then interest rate in the next period would be equal to this previous plus the change. And again, now the change would be based on the newest observation we have. So I just copied the formula, and now RT is taken from my period number 0 after I begin my simulation. And again, new level is equal to previous one plus the change, and so on. So I started with 2%, and I should be getting closer to the mean level, and this mean level is about 3.6, so it's about here, right? I am pretty close to, usually I'm getting closer and closer, and of course the behavior and how this chart looks will depend on assumption on speed reversion. If you use very fast reversion here, you of course see immediate jump and then some stabilization around the mean. Just this volatility will be important, right? If you have 20%, you will be getting closer and closer, but gradually if you have just 1%, of course most probably you will get up, but it will require more observations. So where you can use this, so usually it's used for like short trade models. From my like practical experience, I saw, for example, in a lot of financial modeling that is used by the big 4 companies in consulting, that they model macroeconomic assumption about the interest rate, especially about the CPI, so about inflation, consumer price index, based on this speed of reversion with their assumptions. So we will also use this Vasicek model for our simulation of the behavior of interest rate. And if you know both geometric Brownian motion, and if you know some models based on long-term mean and reversion for interest rate, you basically have like the most important markets covered. Even though this is a very like simple approach, the logic here is like very important and can be applied directly for valuation of some example derivative instruments.